Welcome to Spider Web Education. We're going to continue our series on logic gates. Today we're going to talk about the AND gate and the OR gate. So let's start with the AND gate. The AND gate, this is the symbol for the AND gate. It has two inputs, A and B, and it has an output, Y. Now if we look at the schematic down below, you can see we have our A input, we have our B input, and we have our output Y. So what we're going to do is we're going to use this circuit, which is just a representation of the symbol here for the AND gate, and we're going to fill in our truth table. Now our truth table, since we have two inputs, A and B, we have four possibilities, 0, 0, 0, 1, 1, 0, 1, 1. So if we analyze our circuit, we can then come up with our output of Y. So if I go with a 0, 0, which means both of these are grounded, if they are both grounded, then my output is going to be 0. If this is ground, then my power is going to flow this way, which because of this isolator on R, this is going to be a 0. Now, if I go 0, 1, which means I leave this grounded, but I take that high, so I get rid of this ground, then I'm still grounded here, so I have power going this way. Nothing's going to really happen here because those are the same state, and I'm still going to get a ground on my output. 1, 0 is really just reversing these. So I take this one, A, high, and I take B low, it's going to be the same as the 0, 1. It's going to be a 0. But if I take B high and A high, both of them are high, and then that will then give me, because I don't have any current flowing to my ground, that will make that point high or 1. So that completes the truth table based on the schematic. Now let's go look at the OR gate. The OR gate also has the outputs A as related to the circuit, and B, the second input related to the circuit, and the OR gate Y. Now, let's fill in our truth table for the OR gate. So, if we ground both A and B, you can see there's going to be no current traveling either way, because the state here is the same as state here. So really, we're just taking Y and we're pulling it to ground through that resistor. So our Y is going to be 0. But if we take and we make A low, or 0, and we take B high to power, now this is really not doing anything because it's the same state as this, but we have power here, so we're going to have current flow this way. Because of this isolator, Y now will be a 1. Now if we reverse those, as we do in this third state, obviously it's going to be the same. We're just putting a high here and a low here, so that's also going to be a 1. But then in the last one, if we take them both high, we will then have a high here, we'll have a high here, and a low here. With this isolator, that will then make my output high. So that completes the truth table for the OR gate. Now, one thing that we're going to start talking about are Boolean expressions. Boolean expressions are the mathematical equation or the mathematical model of our truth tables. So if we look at this closely, we have an A, we have a B, and we do something to those and we end up with a Y. Well, if you look close, we have a 0, 0 gives us a 0, a 0, 1 gives us a 0, a 1, 0 gives us a 0, and a 1, 1 gives us a 1. So really we can say A times B is equal to Y. And it's the same for all 4 of our states. 1 times 1 is 1, and so forth up the truth table. Now, if we look at our OR gate, we can put a plus in there. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1, well, it doesn't equal 2, but remember, we're dealing with binary numbers, base 2, we can only have 2 numbers, so therefore, our number here has to be a 1. So 1 plus 1, believe it or not, is a 1. That's our Boolean expression for our OR gate. So, what have we done? We talked about 2 logic gates, the AND gate and the OR gate. We have the symbols for each one, we have the circuit representation for each one, and we use that circuit to create the truth table, and then we use that truth table to create the Boolean expression. All right, if you have any comments, please leave them below, and as always, please subscribe to Spiderweb Education.